You know, for decades, the entire world of advanced computer chips has basically been run by two giants. One company, they make pretty much all of the most powerful chips, and another company, they build the only machines that can actually print them. It's a system, a balance of power that has seemed totally permanent. Well, until now, because a small startup is making a claim so wild it's almost hard to believe.
Okay, let's really unpack that for a second. A quote like that is serious business. We're talking about a technology that could literally rewrite the rules of an industry that, let's be honest, powers our entire digital world. So, to really get what this revolution could mean, you first have to understand the empire they're trying to overthrow. See, the world of advanced chips is ruled by two kings, and each one has its own untouchable kingdom.
And this table just lays it out perfectly. It's a beautiful symbiotic relationship. You've got TSMC over in Taiwan, and they are cranking out something like 90% of the world's most advanced chips. And then you have ASML in the Netherlands. They don't make the chips themselves, they build the one single essential tool you need to make them. And on that tool, they have a 100% monopoly. It's the perfect unbreakable partnership.
Now, the secret sauce to all this dominance is a process called lithography. The basic idea is actually pretty simple. You're just printing circuits onto silicon. But the scale? The scale is what's absolutely mind-bending. We are talking about printing features thousands of times smaller than a single human hair. And to print something that tiny, you need a very, very special kind of light.
For years, the industry used what's called deep ultraviolet, or DUV light. But physics has this hard, annoying rule. You just can't reliably print things that are smaller than the wavelength of light you're using. So the industry had to make this absolutely radical leap to extreme ultraviolet, or EUV. And just look at that difference on your screen. We went from 193 nanometers all the way down to 13.5. That one single change is the reason we have the powerful chips in our phones and in those massive AI data centers today.
But here's the catch. That incredible EUV technology, the one that honestly seemed like a miracle, it's now slamming into a wall. And it's a wall made of physics, but maybe more importantly, it's a wall made of money.
Okay, so here's the crucial problem. Even with that super short EUV wavelength, we can't print the tiniest features in a single pass anymore. The source material used this brilliant analogy. Imagine you're trying to draw a super fine grid, but the marker you have is just too thick. You can't do it, right? So what do you do instead? Well, you draw every other line first. Then you perfectly shift the paper, or in this case, the silicon wafer, and you draw the lines in between. It works. But every single extra step adds complexity, it adds time, it adds a huge risk of mistakes, and boy, does it add a ton of cost.
Let's talk about that cost. This is how much a single new high-NA EUV machine from ASML costs. $500 million for one tool.
And because you need a lot of those tools, this is the projected cost for a single advanced factory, or what they call a fab, by the end of this decade. $50 billion.
Which brings us to this number, $100,000. That's the projected cost for a single processed wafer of silicon. At these prices, innovation stops being something for everyone and starts becoming a luxury that only a few megacorporations on the planet can even afford.
This is what happens when you just keep pushing the same technology over and over, even when the costs are exploding way faster than the benefits. And it leads you to ask a really fascinating question. What if we're trying to solve the wrong problem entirely?
And this is where a US-based startup called Substrate comes into the picture. They are proposing a totally, radically different path. They're not trying to make EUV better. They want to abandon it for a technology that's actually been sitting around in research labs for decades.
They are betting everything they have on X-ray lithography. X-rays have a much shorter wavelength than even EUV, which in theory makes them absolutely perfect for printing unimaginably tiny features. The problem has always been, how do you control them?
And this right here illustrates the difference in philosophy perfectly. EUV, with all its complicated multi-patterning, is like sketching a masterpiece one painstaking line at a time. Substrate's goal with X-rays? It's to be a stamp, to print the entire complex pattern in a single clean exposure. It's a total shift from complexity back to simplicity, and that has the potential to just slash the costs.
So how did they crack that control problem that's plagued this idea for years? Well, for decades, the only way to generate stable, powerful X-rays for this kind of work was with something called a synchrotron, a massive particle accelerator literally the size of a city block. Not exactly factory-friendly.
Substrate's big claim is that they've compressed that same science into a compact source that can actually fit inside a normal factory tool. If that's true, it's an absolutely incredible engineering feat.
But here's where the story gets really wild. See, building a revolutionary new tool is one thing, but Substrate realized that just selling a new tool isn't enough to break the iron grip of the giants. No, their plan is much, much bigger than that.
This is their big gambit. They have no intention of selling their machines to TSMC or Intel. They want to build their own factories, using their own tools, and then sell manufacturing services directly to companies like Apple and NVIDIA. Think about that. They are not trying to be the next ASML, they are trying to be the next TSMC.
Of course, let's be realistic. The road ahead for them is just filled with these monumental challenges. They have to reinvent pretty much everything. The light-sensitive chemical coating on the wafer, the masks that hold the patterns, the optics. And they have to prove they can do this not just once in a controlled lab, but millions of times a day with near-perfect factory-level reliability.
And let's be crystal clear, they are not just fighting a technology problem here. They are going head-to-head with TSMC's decades of manufacturing discipline, their unbelievable, mind-boggling scale, and hundreds of billions of dollars of sunken investment. Just having a better mousetrap is not enough to win this fight.
So with the stakes being this high, and the challenges this huge, why does this battle matter to the rest of us? Well, the answer might actually be found in a completely different industry: space travel.
For years and years, launching anything into orbit was just fantastically expensive. Then SpaceX came along and they changed just one core assumption, that rockets had to be thrown away after you use them once. By making them reusable, they just cratered the cost by an order of magnitude, and that changed everything.
And that brings us to the ultimate question of this whole story. Could Substrate's technology do for computer chips what SpaceX's rockets did for launching satellites? Could this be that SpaceX moment for semiconductors?
Because if they succeed, if they actually pull this off, the consequences would just be enormous. It would mean startups and universities could actually afford to design cutting-edge chips again. It would mean faster design cycles, way more experimentation, and a huge expansion of computing power for AI and whatever comes next. It would be a true democratization of the single most important technology shaping our future.
So, we're left at this incredible crossroads. Is Substrate on the verge of kicking off a whole new era of computing, breaking a powerful monopoly and unlocking a massive wave of innovation? Or is this about to become a very, very expensive lesson in just how impossibly difficult and how deeply unforgiving the business of making chips truly is? Only time is going to tell.